Well, good morning everybody. My name is Dr. Martin Hendry from the School of Physics and Astronomy at Glasgow University. Now, as you can probably tell, I'm not in Glasgow University today. I'm joining you from Los Angeles, from very close to Hollywood in fact. I'm here at the Griffith Observatory, which is in Los Angeles. It's one of the most visited observatories in the whole world because, of course, it's close to a very, very big city. Now, big cities aren't an ideal place to do astronomy these days, but when this observatory was built, there was much less light pollution in Los Angeles than there is today. And that means that you could see the night sky much more clearly. But the telescopes we have here at the Griffith Observatory are not really the biggest in the world. They never were, in fact. But quite close to here, in the hills just behind Los Angeles, behind the city of Pasadena, there was an observatory called Mount Wilson, where in the early 1920s, a very famous astronomer called Edwin Hubble was able to use those telescopes to learn some fascinating things about the universe. Edwin Hubble was studying distant galaxies, and he was doing it at a time when people didn't even really know what galaxies were. We live in a galaxy called the Milky Way, and when Hubble was around, we began to realise that there were many other objects out there in space which looked a bit like the Milky Way, but we didn't know how far away they were. And Hubble's observations with a telescope that was 2.5 metres wide, that means it was probably a good fraction of the size of your classroom, that telescope allowed Hubble to see some galaxies which were millions of light years away. So far away that the light had been travelling towards the Earth for millions of years. And I'm here in Los Angeles because this week, National Science and Engineering Week back in the UK, I unfortunately can't be with you because the research collaboration that I'm part of is having a meeting here in Los Angeles to discuss a whole new different type of observatory called a gravitational wave observatory. So in the future, perhaps by the time you're all leaving school and beginning to think about what you might study after that, we hope to have begun to observe gravitational waves coming from other galaxies and distant stars far away in the universe. But back in the time of Hubble, the way we studied the universe was using light. And because light travels at a finite speed, it does travel very fast, 300,000 kilometres every second, but that still means that the light from these faraway galaxies takes a long time to reach us. So, looking out at the universe at very distant galaxies, you're actually looking back in time. And what Edwin Hubble learned by studying these distant galaxies was that our universe appears to be expanding. It's getting bigger all the time. And that helped Hubble and other scientists over the following 30 years or so to develop a theory that we call the Big Bang Theory that explains how our universe began. So now in 2011, nearly 100 years after Edwin Hubble made those first discoveries, we think that our universe is about 13,000 million years old. And it all started with the Big Bang more than 13,000 million years ago. And that really is the project that you're going to be studying this week in National Science and Engineering Week. You're going to be learning about the age of the universe and some of the things which have happened in our universe since those very earliest moments after the Big Bang. Now, if you think of the age of the universe like one calendar year, that means turning 13.7 billion years into 365 days, then, well, human beings only appeared on the Earth about 4 minutes to midnight on the 31st of December. So we're relative newcomers in the age of the universe. The universe has been around a long time before human beings appeared. So you can think about the age of the universe like 1 year, but there's another interesting way to think about the age of the universe. Think about it in terms of what's changing in the very earliest times and what's changing later. Think about it when you were very little. After you were 1 year old, the next year you were going to be 2 at your next birthday. That means your age had doubled in only 1 year. But then it would take another 2 years before your age would double again, and then another 4 years before it doubled after that, and so on. So the project that I'm leading with the schools in Dumfries and Galloway this week is to learn a little about how we can think about the age of the universe in terms of the time it takes for the age of the universe to double. In fact, we're going to do it using trees. We're going to use a very large tree from the Galloway Forest, and what we're going to do is to build a display to describe the age of the universe in terms of the rings of that tree, going all the way from the earliest moments after the Big Bang to the present day. And every time we go to a new ring of the tree, we're considering the universe being 10 times older than it was before. And with a tree with about 60 rings, we can describe how the universe has changed from its earliest moments after the Big Bang all the way to the formation of our Milky Way galaxy.